Okay, thanks everyone for joining for today's showcase presentation. Today, I'm really excited that we have Amy Barchauskas here with us. Amy has been a data engineer at Development Seed for over 6 years, and she works with NASA Impact to make Earth observation data cloud friendly. And I'm super excited that she's agreed to present today on the VEDA platform. So thank you, Amy. Please take it away.
Great. Yeah, thanks, Max. Yeah, I'm excited to be here today to talk about VEDA, which is NASA's open science platform, and it stands for Visualization, Exploration, and Data Analysis. So I'm going to describe a little bit about the platform and why we decided to create a new platform, the technology, and also the value behind such a platform. So what is VEDA? So VEDA is a platform, like I mentioned, that offers exploration, analysis, and science storytelling. And you can check it out at earthdata.nasa.gov/dashboard if you want to learn more. And I like to think about VEDA in terms of how it supports this virtuous open source science lifecycle. So starting with the top where VEDA allows scientists to tell stories. And then anybody can go to VEDA and discover those stories and explore science data. And once they've done that, once they've explored that data, they can take that data into diving deeper through data processing, modeling, and analytics. And they might discover something new, have some new insight to share, some new data product that they created, and then they can basically bring those results back and make those new results available in a VEDA platform application. And I also wanted to emphasize that VEDA supports reproducible science. So, for example, one way that we do this is we allow users to integrate, we allow scientists to integrate notebooks into their science storytelling. So in this example, we've linked up a notebook describing this data set with a way to explore that data set on our VEDA Jupyter Hub. So we want to integrate more of this sort of reproducible science into our VEDA dashboard applications. So NASA's open source science initiative has these four pillars, and VEDA is a part of NASA's open source science initiative. So I just wanted to mention these four pillars today because today is part of our community engagement. While VEDA is also part of the core data and computing services, the reason why we're here with Pangeo is to engage with this community. And this community is special to Pangeo because is special to VEDA. The Pangeo community is special to VEDA because a lot of our platform and some of the values that we stand on, like open source, open software, open data, wouldn't be as powerful today without the Pangeo ecosystem and community and tool set. So I'd like to posit the answer to the question of do we need platforms is yes. And that's because at least one reason why we need platforms is because the scale of data, along with the need for open science, requires accessible data and platforms. But we don't need to invent new tools. So I don't think this should come as a surprise to anybody, but there's a lot of really amazing tools for doing open science on petabyte scale data archives that have been developed by this community and others. But do we need new platforms? There are platforms that already exist. And again, the answer to this we feel is yes. So with the VEDA and our stakeholders, we found a need for science-specific and project-specific applications. So there is a need for basically custom interfaces for specific data sets and specific domains, which I'll talk a little bit about with respect to the Greenhouse Gas Center. But basically, yeah, so different projects and different science-specific applications need their own dedicated interfaces and development environments. So this is one of the ways that VEDA is very powerful. So it offers a collaborative, interoperable framework adaptable to specific scientific domains and projects. So like one of our first success stories is the Greenhouse Gas Center. So VEDA was redeployed and for the Greenhouse Gas Center, and it was built in 4 months with 13 data sets and 4 data insights. And so you can go learn more about the Greenhouse Gas Center initiative at earth.gov/Greenhouse Gas Center. So one of the really powerful ways that VEDA is changing the science community and ecosystem, like the community ecosystem around science, was really explained well by James Colliander, who described VEDA as a new style of public good. So VEDA, like I mentioned before, is building upon a lot of the momentum around open source, open data, and open science by providing infrastructure and tools for policymakers and citizens to engage with EO data in a completely open and accessible way. So I'm just going to read this quote by James because it really inspired me to continue to work on this type of thing. So he says, research, data, and recommendations developed by scientists and engineers that influence policies set by democratic governments should be accessible by voters. No entity should own the ways humans communicate and learn about the Earth system. The U.S. Greenhouse Gas Center's generous approach to digital infrastructure and open toolchain adjacent to open data is vital for democracy and should be replicated across government agencies worldwide. So how did we do it? So this is kind of a busy diagram, but I really just wanted to annotate all of the VEDA infrastructure with the different open source tools and even enterprise tools like ArcGIS that we have integrated into this platform. So I really just wanted with this diagram to show how VEDA, the platform, in addition to being a place where you can do open science, is a way to is a platform that integrates all of these existing very powerful tools. So how did we create VEDA? So VEDA is based in a core data system that marries PostgreSQL with Stack, or the Spatiotemporal Asset Catalog, for cataloging geospatial data. So we keep coming across the same problem across many different organizations which is that they have large scales of Earth observation data that they want to make available and accessible through data services for visualization and access. And so through these experiences, we developed a reusable set of Stack-focused technologies that could be reused to serve these different use cases. So that's why we just developed PG Stack, which is a Postgres schema for that Stack metadata that I mentioned, that spatiotemporal asset catalog metadata for cataloging your geospatial assets. So once you have this PG Stack database, it enables a lot of different services on top of it. And that's what I'm going to talk about next. So this all starts with putting data on the cloud in Cloud Object Storage, and then cataloging it in PG Stack, and then making it discoverable with Stack Fast API. And then there's a library called T-Tyler PG Stack for visualization. So this enables sending queries in the parameters to create query-driven dynamic visualizations. And then it also provides a OGC features API to make that data accessible. And this core data system is what we call EO API. And you can learn more about EO API at eoapi.dev, including how to deploy it as one deployment, one set of infrastructure. You can reuse EO API for many different types of applications. If you already have your Stack items and collection set up, the amount of time it would take to set up a new Stack catalog with these services on top of it is less than an hour. So once you have these core data services, we can layer on different types of applications that can be customized for different project or domain-specific needs. So for the VEDA platform, those specific applications that I'm going to talk about are the VEDA dashboard and the development environments. So the cool thing about the dashboard is how it's configured. So when you go to earthdata.nasa.gov/dashboard, you would see many different data sets and data stories. None of that content comes with the core UI components, which are React.js. They are all configured in Markdown files in a separate repository called VEDA config. This makes it really easy to configure the VEDA dashboard with different data sets and different stories, modify and add them in a way that doesn't require any code. We are refactoring the VEDA UI, and I'm not going to spend too much time on this, but what we basically saw was a need for greater composability when it came to dashboard applications. So in speaking to stakeholders about VEDA, we found that a lot of different parties were interested in different types of pages and interactions and ways to tell stories. So at the moment, we're undergoing a major refactor of how the VEDA dashboard works, which is basically to have VEDA UI components as part of a component library that can be imported and pulled into different instance-specific pages. So the VEDA platform also can come with a development environment. So the VEDA Jupyter Hub that I showed earlier in some screenshots is deployed and managed and developed many great features by 2i2c. So in these screenshots here, I've wanted to show how basically you can select different types of development environments. So this is really cool features that 2i2c has provided, such as the ability to, in addition to the Pangeo notebook Jupyter Hub environment, you can also use QGIS, you can use RStudio, and you can even use a custom image. And that's really powerful because, even in this specific example, like I'm using an image that Max created. Also, thanks to Max, you can launch a VEDA Jupyter Hub instance and then use VS Code within it. So that's all really exciting and changed the way that I develop on a regular basis because I don't have to manage environments anymore. A lot of the development I do is using the VEDA Jupyter Hub. Another reason why I use big reason why I use the VEDA Jupyter Hub is because of its data access. So we've configured role-based access to many Earth Data Cloud buckets. And that means that we don't have to use we don't have to use Earth Data Login to request data from those Earth Data Cloud buckets. And this, greatly simplifies some of the workflows that we have for working with data when we don't have to worry about Earth Data Login. So where is VEDA going? We are planning a number of new domain-specific VEDA instances in the coming years, and we will continue to integrate cutting-edge geospatial technologies and make it easier to customize new instances. And then finally, how can you get involved? So you can join us on the Jupyter Hub instance, hub.openveda.cloud, by sending an email with your GitHub username to veda@uah.edu. And if you don't remember all that, you can navigate to the documentation, which also describes how to get access. You can see there's a link to getting access in the navigation. And the documentation website is also a really great resource for learning more about VEDA, both as an open source ecosystem, as well as it provides a lot of resources for learning about how to actually do science with data on the cloud. So it provides a lot of tutorials, quick starts, and more details about specific data sets on the platform. So pretty much anything that you might want to know about VEDA, you could probably find on this website. Okay, so in summary, VEDA integrates an existing ecosystem of open source tools developed by this community, including those developed by this community to create a platform for open science that emphasizes interoperability. VEDA can be replicated for different science domains. The first instance of this is VEDA. The first instance of VEDA, the Greenhouse Gas Center, can be seen as a digital public good, which enables policymakers and citizens to engage with EO data. And then finally, just about how to learn more, explore and learn more. So that's the dashboard link, the docs, which are docs.openveda.cloud. And then there's the Greenhouse Gas Center website, which is you can just go to earth.gov and you can find it from there, or you can go to earth.gov/GHG Center. And everything that I've talked about today is open source. So this is non-exhaustive, but just wanted to, share that all the repositories for all of these different tools are available on GitHub publicly. And that's it. All right. Thanks. And I'm happy to take questions.